R is the correlation coefficient. So R is always a value between -1 and 1. Okay? The closer R is to +1, let me go back and we'll review those other problems that we were looking at. Okay, this is an R value of a perfect -1. Okay? Again, it doesn't exist in the real world. It's just kind of an extreme to give you an indication of how strong your linear relationship is. Okay? An R of +1 would line up in a positive manner, perfect linear correlation. Okay? As your values start to drift away from the line, your R starts to pull back a little bit. So it's kind of like, let's say here's -1, and here's +1, and here's 0. So let's say we have a strength meter, an R strength meter, okay? Kind of like a
Metal detector?
yeah, or what's it's called the Richter scale, off of like an earthquake detector. Okay, so over here we've got strong positive negative linear correlation. Okay, although not realistic. And the closer R gets to 0, the weaker that linear relationship from either side. So what we're looking at is we want our R value to be either toward -1 or toward +1. In the middle, it means that we really don't have, when R is close to 0, it means that we really don't have much of a linear relationship at all. Now, we might have another type of relationship that's completely valid, but just not a linear one. So remember, this is the linear correlation coefficient. Okay, so does that kind of make sense? It's a very subjective thing. You're not going to have to worry about how strong is strong enough. Okay, all the R values that you deal with in your homework and stuff are going to be at least 0.5, -0.5, and beyond. Okay, and that's about as good as you can expect to do in real life. 0.4, 0.5, -0.5 is pretty rocket. I mean, if you go out and collect real sample data and you get, say, a positive -0.5, you're happy as a clam. Okay, so our calculator calculates the R value for us. You can see in the notes what a horrible calculation that is, huh? Not a lot of fun. But the R value, or the calculator is going to do that for us. So let's back up. Yay. Okay, so once you have your paired sample data in there, all right, let's go back to the home screen, second, quit. And we're going to calculate the R value, okay? So you want to hit Stat and one right-hand arrow. This is a familiar menu, right? We did our one variable stat in this menu. Now you want to go down. Oh, and I think, do I have it in the notes where it's B1x plus B0? Yes, okay, I got it. Sometimes they put and it's most common that the y-intercept goes in front and not as the second term. You with me? In algebra, right, you've got your x term and then your constant on the end, and the coefficient of the x term tells you your slope, the constant on the end tells you your y-intercept, right? Okay. A lot of times in stat, what we do is we call all of the constants b's, and The intercept is called B0, B with a subscript 0, or B naught, like NAUGHT, okay? And the slope is given with a subscript of 1. And this is because, if you think about it, there usually is many more than one variable that you use to predict another variable. Let's say you're going to buy a house, right? How many different things do you think about when you're going to buy a house, right? You've got the neighborhood, does it have a pool or not? How many square feet? How many bedrooms? How many bathrooms? Size of the, maybe a cabinet space in the kitchen. You know, you look at all these different things, right? The age of the house, the condition of the house, if you can quantify that. So we give all of the coefficients B's because there's usually a whole bunch of terms in this equation. We're starting off just on the scratching the surface, okay? So we go down to, I got so sidetracked, I'm like, where was I going with that? So we go down to number 4, linear regression. And then enter the location of the x variable, whoops, followed by the location of the y variable. So just whatever lists, sorry?
Does it need to be in that order?
Yes, yes it does. It has to be in that order. Thank you for bringing that up, Erica. So you want the location of the x variable, comma, location of the y variable, whatever list you put them in. Okay, and then you hit enter.
How come there are parentheses as AX plus B?
How come there are,
It's not, like right there in the parentheses, it wouldn't be B1X with B0.
no, the calculator has its own, thanks Scott, the calculator has its own notation. So it gives it to you, it gives you the output more in like an algebraic notation than a statistics notation.
But that's the
So their A is our B1, and their B is our B naught. Does that make sense?
In the calculation, okay.
Yeah, in the calculator.
So,
So then you hit enter, and you get all this good stuff out the bottom, including your R value. Did you not get the R value? Okay, if you did not get the R value, there's something in the calculator that turns the calculation for R and R squared off. I have no idea why, but this is what you do. So clear that, go second, 0. Second, 0. It takes you into your catalog. Now you hold your finger on your down arrow. And you're going to get to, the stuff is in alphabetical order. You're going to get down to these commands, diagnostic off and diagnostic on. Put your little cursor in front of diagnostic on. Hit enter twice. Enter once takes it to the home screen. Enter twice activates it. And now you'll be able to get the R squared. Or the R and the R squared. It's a really weird thing. I don't know why it does that.
Does that take you a while to find out?
Sorry?
Does that take you a while to find out?
I think I had to look in the book for that one. Every once in a while, I do read the manual.
I got a different R. Maybe I put in my.
Yeah, if you got a different R, you probably mistyped a number.
Really close.
Really close? Yeah, you probably just mistyped a number. So our R value here is to 2 decimal places. It's 0.70.
Maybe we're right. I think we're right.
So there's a lot of ways, okay, to look at this, right? This is a pretty, it's a moderately strong, positive, linear trend. It describes a moderately strong, 0.7, yeah, not too bad, huh? Positive, because R can be positive or negative, depending if the data goes this way or this way, okay? Linear, all important, trend, let's write it. R of .70 indicates a what did I say, moderately? You just say pretty strong, moderately strong, positive, linear trend between, and remember this is an application, so it's between bare weight and bare length, yeah? Okay, does this make sense so far? So the parts here, the positive, linear, you really want to stress. The moderately strong, you know, any words that you have that are similar, it's fine. Yeah, Mike.
So the positive trend, what is that telling us?
It tells us that as, okay,
Oh, basically the longer the bear, the more food it
Yeah.
eats?
the
bigger, more
the
weight?
more weight it has, yeah. So the positive part tells us that as bear length increases, bear weight increases as well. If it were a negative trend, it would tell us that as the X value increases, the Y value decreases. Okay? Note that X is in this application is also called the predictor variable because we're going to use it to predict bear weight. And Y is called the response variable because it responds to the bear length that we're going to put into the system. It actually is what does the calculation or the prediction. Okay, so there is our R value. It's looking pretty good. Our next step might be, well, let's go ahead and get the equation of the line, which is right here for us, right? So your model is at the top, the AX plus B. You're going to take this value of A, put it in there for A. You're going to take this value of B, put it in there for B, and then we'll talk about it. So we've got and also in regression, Y wears a little hat. And that's because it's being predicted. Okay? So something that's something that is being predicted in statistics wears that little pointy hat, the little dunce cap. So Y equals 1.68 X plus, oops, actually that's a negative, minus 139.95. So far so good? You guys with me?
My values for A and B were different.
Yeah, I think she
Mine too.
answered it wrong.
Are they different? Did I make a boo-boo maybe?
So,
Boo-boo?
Yeah, we got,
I double checked.
You double checked yours? Okay, let me,
it's really close.
really close? All right.
Here.
Thanks,
We're at
guys.
A plus